Hello, and welcome to our Spring Boot tutorial series. In this series, we'll dive deep into various aspects of Spring Boot, helping you to build robust and scalable applications. Today, we are going to explore RESTful services and how you can use them to build powerful applications. Let's get started. Picture this. You're planning an epic trip to Goa. What's the first thing you do? You grab your phone and open a travel app to book your flights and hotels. Have you ever wondered how this app magically knows all the flight schedules? Well, today, we're going to uncover that magic. Let's break it down with an example. Say you want to fly from Delhi to Goa. You enter your details into the travel app, and it instantly shows you a list of flights. But how does the app know this information? The travel app itself doesn't store flight schedules. Instead, it fetches this information from various airlines, which are third-party services. Here's where the real magic happens. How does the travel app communicate with different airlines? What languages do they use? And in what format is the data received? Airline services run on different servers with their own databases, while the travel app runs on its own server with a different database. Directly accessing the airline's database isn't an option because databases aren't exposed to the public. So, how does the travel app get the flight details? This is where web services come into the picture. Airline services expose certain web service APIs, such as search flight details and book flight. The travel app makes an HTTP call to these web services. When this call reaches the airline service, the airline's code executes, fetches the flight details from its database, and returns the data. But wait, there's more. What if the airline's code is written in Python, and you're developing your travel app in Java? Can you still fetch the data? Absolutely. Web services don't restrict us to a particular programming language. The airline service can be coded in any language like C++, Java, or Python, and you can write your travel app in your preferred language, be it Java, C++, or Python. Now, you might wonder, if the airline service is in Python and my travel app is in Java, how does the communication happen and what data format is used? Communication between a travel app and an airline's web service occurs through HTTP requests, and web services provide a standard format for data exchange, such as JSON and XML. These formats are universally understood by different programming languages. So, the airline service sends data in one of these standard formats, and the travel app can easily process it. Let's talk about what a web service is. A web service is a way for different applications to communicate over the internet. Think of it like a bridge connecting different systems, allowing them to exchange information seamlessly. This enables various software systems to work together without requiring custom code for each integration. Web services allow different applications, written in various languages and running on different platforms, to communicate with each other. They use standardized protocols like HTTP, XML, SOAP, and REST to facilitate communication. These web services are commonly used for tasks like fetching data from a third-party service, integrating with external systems, or enabling functionality in mobile and web applications. Now, you might wonder, is everything exposed on the internet a web service? No, that's not the case. Not everything exposed on the internet is a web service. While web services are a subset of what is available on the internet, they are specifically designed to enable communication between different software applications over the web. When you open a web browser and visit a website, you are typically interacting with a web application, which serves web pages to users. These web pages are intended for human consumption and are rendered in a way that is visually appealing and easy to navigate. On the other hand, web services refer to APIs, application programming interfaces, that allow software applications to communicate with each other over the internet. These APIs expose endpoints that can be accessed programmatically to perform operations or retrieve data, often in a machine-readable format like JSON or XML. There are two main types of web services, SOAP and REST. SOAP stands for Simple Object Access Protocol. It uses XML to send messages between systems. It's highly standardized, ensuring consistent communication across different platforms. SOAP can be a bit more complex and slower because of its reliance on XML and additional standards. It's often used in enterprise-level services that need robust security and transactional capabilities. REST, which stands for Representational State Transfer, it uses standard HTTP methods like GET, POST, PUT, and DELETE. It's designed to be simpler and more flexible than SOAP. REST is more commonly used today because it is lightweight, easy to implement, and highly efficient. It's perfect for web and mobile applications that require fast and scalable communication. Now, let's focus on RESTful services. They have become very popular because they are simple and efficient. REST, or Representational State Transfer, is a way to design web services that allows different applications to communicate over the internet. It is based on a set of principles that make web services lightweight, maintainable, and scalable. In simple terms, REST is a method for creating web services that lets different programs talk to each other online. It uses standard web protocols like HTTP. RESTful services are designed to be simple, fast, and reliable by following specific rules. RESTful services were introduced by Roy Fielding in the year 2000. His idea was to create a system that's easy to use, scalable, and high-performing. 6 Guiding Principles of RESTful Architecture. First, we have statelessness. This means that each request from a client to the server must include all the information needed to understand and process that request. The server doesn't store any context or session information about the client between requests. For example, when you search for something on an e-commerce site, each search request you make is independent and doesn't rely on previous searches. This stateless nature makes RESTful services scalable and easy to manage because each request is independent and self-contained. Next, we have the client-server architecture. This principle separates the user interface concerns from the data storage concerns. By keeping these responsibilities separate, the client and server can evolve independently. For instance, a mobile app, client, can request data from a server that stores product information. The app can update its user interface without affecting the server, and the server can update its data storage methods without affecting the app. This separation enhances scalability and flexibility. The third principle is cacheability. Responses from the server must define whether they are cacheable or not. If a response is cacheable, clients can store and reuse this data for future requests. For example, when you visit a news website, the latest articles might be cached on your device so that if you revisit the site soon after, the articles load faster without fetching the same data again. This reduces the load on the server and significantly improves performance. Moving on, we have the uniform interface. RESTful services use a standardized way of interacting with resources, typically through URIs, Uniform Resource Identifiers, and HTTP methods like GET, POST, PUT, and DELETE. Then, there's the layered system. In this approach, a client cannot tell whether it is connected directly to the end server or through an intermediary, such as a proxy or load balancer. This layered architecture enhances security and scalability by allowing intermediaries to manage different aspects of the system, such as authentication, logging, and load balancing, without affecting the client-server interaction. For example, when you access a web service, your request might go through a load balancer that distributes the request to one of many servers, ensuring that no single server is overwhelmed. Finally, we have code on demand, which is optional. Servers can extend or customize the functionality of a client by transferring executable code, such as JavaScript. This capability allows for dynamic updates and enhancements on the client side. For instance, when you use a web application, the server might send JavaScript code that gets executed in your browser to add new features or improve user interaction without requiring a full-page reload. This makes the application more dynamic and responsive. These principles collectively ensure that RESTful services are robust, scalable, and easy to maintain, making them a cornerstone of modern web development. Let's talk about the common HTTP methods used in RESTful services. These methods define the actions you can perform on the resources in a RESTful API. Get method. The get method is used to retrieve information from the server. This operation should not modify the resource. For example, when you visit a web page or fetch data like user details, product listings, or search results, you're using a GET request. It simply asks the server to send back the requested information. Post method. The post method is used to send data to the server to create a new resource. For instance, when you fill out a registration form and submit it to create a new user account, a post request is made. It tells the server to take the provided data and create a new resource based on it. Put method. The put method is used to update an existing resource or create a new one if it does not exist. For example, when you edit your profile information on a website, a put request is sent to update your details. If the resource doesn't exist, put can also be used to create it. Delete method. The delete method is used to remove a resource from the server. For instance, when you delete a post on a social media platform, a delete request is made. It instructs the server to remove the specified resource. These HTTP methods form the backbone of how we interact with RESTful services, allowing us to perform all necessary operations to create, read, update, and delete resources efficiently. In RESTful services, data can be represented in various formats including JSON, lightweight and easy to parse, XML, flexible with support for complex data structures, HTML, used for web content, plain text, simple and human-readable, YAML, human-readable data serialization, CSV, tabular data, protocol buffers, efficient binary serialization by Google, message pack, binary format similar to JSON but faster and smaller, and Avro, binary format with strong schema support. The choice of format depends on factors like human readability, data size, interoperability, and schema support. That's it for today's video. In the next episode, we'll show you how to create a RESTful service using Spring Boot. If you have any questions or comments, please leave them below. Don't forget to like, share, and subscribe for more updates. See you next time.